Good morning, friends. This is Radhakrishna Bhupdesi. So our topic is second session here. The topic content is the steam power plant. Okay. So already we discussed in the last class regarding the introduction of a power plant. So what is meant by a power plant? What are the advantages of a power plant and what are the disadvantages of a steam power plant? And also we discussed about the layout of a steam power plant, working circuits, and types of energy sources. So these are the discussed in the session 1. In the session 2, I would like to introduce a types of fuels. So how to can utilize the fuels and what are the different modes of a fuel. And especially in a steam power plant, we are using coal as a fuel. Okay. So already do you know that how the coal is generated and what are the different types of coal. So in this session, we can clearly discuss about the different types of fuels. At the same time, I would like to introduce types of fuels too also. Okay, so coming to the lesson. So this is totally covered with a steam power plant. And next one. And already we discussed that different layout of a steam power plant. So this is a simple layout of a steam power plant. So what are the important components of a? Once again I will recap all the things. So what are the important parameters of a steam power plants or components of a steam power plant? So in the steam power plant, the main components, as of you know, the first thing is the boiler, and second thing is the air preheater, and next thing is the superheater, and next one is the turbine, and next one is the generator, condenser. Okay, so these are the very important components of a steam power plant. So now we can see the layout of a steam power plant here. So see here. So this is your boiler. So this is your boiler here. So what is the use of your boiler? So boiler is a device which converts water into the steam format. So how the water is converted into the steam? So for that purpose, what we need to do? So first of all, we need to supply heat energy. So how the heat is generated? Okay, the simple thing. So we are supply the fuel for a steam power plant is the coal. So we need to use the coal storage process and the coal storage point to the coal handling plant. So we need to supply the coal handling coal to the furnace. So here we have some more combustion chamber is there. That combustion chamber is known as a furnace. Okay. So in a furnace we are giving the coal and at the same time so we need to supply the fresh air. So for a combustion process, the two important parameters we require is the one is the fuel and second one is the oxygen. So for that oxygen we are taking the air, fresh air from the atmosphere and we are supplying the coal. Okay. So after that coal and the air is here, so the furnace, in this furnace combustion takes place. So due to the heat release of a coal burning, that heat is absorbed by water. At a certain point, that water is converted into the steam format. So what is the boiling point of a water? So generally we know that the boiling point of water is 100 degrees centigrade. After the 100 degrees centigrade, the water is converted into the steam format. But we can't sure that at a 100 degrees centigrade, the entire water is converted to a steam format. Okay. So that purpose, but the thing is, if the total water is not converted into steam format means it contains some water vapor. If the water vapor is available in a steam, it causes maybe corrosion problems. So that's why we need to remove the water content from the steam. So the pure air, the dry, after the removing of entire water content, that steam is known as a dry air or dry steam. So how we can achieve the dry steam? So for example, here we are giving the heat to the boiler by a furnace, and here some amount of heat is water is present in the steam. So that is removed by a superheater process. So here we are using the superheater. So this is the superheater. What did by the superheater? So we need to give some amount of heat. So what are the exhaust gases? After the burning process in a furnace, we are having exhaust gases. So that exhaust gases are using the heating purpose and a superheater also. So in a superheater, and also we can provide the external electrical power. Okay, so based on that high temperatures, that superheater removes the water content from the steam. So now we can get the dry steam. Okay, so that dry steam flows towards the turbine. So what is the function of turbine? Turbine is a device which converts kinetic energy into the mechanical energy. So what is meant by kinetic energy? So the steam have a moving with some velocity. So which of the object having a velocity, so that is known as the kinetic energy. So the main aim of our is, so we need to convert the kinetic energy into the mechanical energy. So for that purpose we are using a boiler. So what happened in a boiler? What happened in a turbine? In a turbine, the steam strikes the turbine blades. Okay, so turbine have blades like this. So the steam strikes like this. Okay. So when the steam strikes the turbine blade, automatically the blade moving some other directions. Okay. So this movement have known as the mechanical energy. So that is the working of a turbine. So here we are getting the initial is we have a coal have a chemical energy. That chemical energy is converted into the heat energy in a furnace. Later, that heat energy is converted into the kinetic energy in a boiler in the form of steam. Chemical to heat energy to the kinetic energy. That kinetic energy is converted into the mechanical energy. This is our final output? No. So we need to generate the electrical energy. We need some another form of the energy. So the main aim of this entire power plant is we need to generate the electrical energy. So how we can generate the electrical energy? So for generation of electrical energy, we need some special device. So that device is known as the generator. It is also known as alternator. So in an alternator, so here the mechanical energy which is having a turbine, so the turbine is coupled with a generator. In a generator, that mechanical energy is converted into the electrical energy. So this is our final output is the electrical energy. Initial input is the chemical energy. So chemical energy is directly not converted into the electrical energy. So that's why we are following these steps. Okay, so this is the one-step process. Later, what are the remaining things? So we need this entire process only we need actually. So this is our input to the final output content process. Okay, but we have several components other than that. So what are the remaining components process? Okay, so here so what are the remaining components thing? So here, observe here, when we are supplying the heat to the boiler or furnace, it contains not only useful energy, so some amount of heat energy is lost in the form of exhaust gases. But my aim is I would like to achieve the maximum efficiency. So when I will achieve the maximum efficiency, when I can use properly to the entire energy generated. But here what happened? The exhaust gases are leaving to the atmosphere. That means I would like to utilize that energy also. So what I can do for the exhaust gases? So simple thing, I can utilize that exhaust gases. So see here, so these are the flue gases. Okay, so what I can do with the flue gases? So the flue gases heat, it have also some heat energy is there. So that heat energy we can utilize for a superheater process. At the same time, after some amount of heat energy is consumed at a superheater, but still I am not happy. It has some more energy, some more heat energy is losses. So that's why I would like to utilize that energy also. So how I can utilize that heat energy? So I can utilize that heat energy by using of an economizer. So economizer is a device which is heated the feeding water. So feed water, we are supplying the feed water to the boiler. So what is meant by feed water? So here the feed water means, so we need to recirculate the water to the boiler. Apart of that, when the boiler is emptied, so we need to fill that water content. Okay, so because the boiler converts the water into the steam, that means water is exhausted. So I would like to introduce the water here. So that process is known as the feed water. So before entering into the water, so we would like to heat that water also. So by using of a flue gases. So this is the economizer. Okay. And later also some amount of heat energy is available in the exhaust gases. I can utilize that exhaust gases also. So we are giving two contents to the burning process. One is the fuel and the second one is the air. So we are taking the air from the atmosphere. So air from the atmosphere means the temperature of the air is based on the atmospheric conditions. But if you increase the temperature of the air, automatically the combustion rate is increases. So the thing is, if you want to increase the combustion efficiency, so we need to heat up the air also if possible. So that process is known as air preheating process. So for that air preheating process, I don't want to utilize any kinetic, any electrical device. So that's why I would like to utilize that heat energy of a flue gases. So see here, so we are using the air preheater. That air preheater is absorb the temperature from the flue gases only. And this is the fresh air taken from the atmosphere. So what happened after air preheater? The air has some high temperature. So maybe that is very useful to us for better combustion process. Okay. Finally, we need a good combustion process. When we get a good combustion process means the amount of heat release rate is very high. So when the amount of heat release rate is very high, automatically the conversion of a water into the steam is increases. So everything, the kinetic energy increases, the mechanical energy increases, finally electrical energy also increases. Okay, understand? And the final thing is, later also we have some other flue gases, and if flue gases are available, so we would like to eliminate that heat energy or flue gases through chimney. Why we are using the chimney? Directly we can allow into the atmosphere. But the purpose of a chimney is, so first of all, what is meant by chimney? So chimney is nothing but a tall tower. So why we are using the tall tower? So if you release the exhaust gas directly into the environment, so it causes to the environmental pollution on the earth's surface. Other than that, we can flow the gases in a high positions, some height. So automatically the high temperature gases are moving always upward directions. Okay, so that's why we can release the exhaust gases in a tall tower. That means it's not directly affects to the environment. Some amount of heat energy is lost up to the top peak points. Okay, so that is the major thing. So that's why I would like to utilize a chimney here. Okay, I think it's clear. Chimney is clear. So now we have completed three things: superheater, economizer, air preheater. Okay, so all these three equipments are utilized in the flue gases only. Flue gases only. And what about the remaining circuits? So simply come here once again. So this is the turbine. So in this turbine, what happens? So the steam is strikes to the turbine blades. So the steam is strikes to the turbine blades. So that means if you observe in your home also, so when we are heating the water, it creates some steam. So above that container, you can place your one plate. So when the steam is touches to the plate, automatically the steam is converted into the liquid format. So here also that is technically known as expanding process. Okay. So here also same process. When the steam is strikes to the turbine blades, the steam is expanded. That means it is converted into the liquid format. It's not converted totally liquid because a high amount of heat flow rate is available, steam flow rate is available here. So that's why some amount of steam is converted into the liquid format. Okay, so that liquid, we would like to convert the entire liquid into the water format. So here high temperature steam is required to convert into the liquid format. So what is the device we can utilize? So simply here we can utilize a one heat exchanger. So heat exchanger means it absorbs always the heat is flow from high to low. Okay. So here we have a high temperature steam. So for heat transfer what we need? A cool content we need. So what is the cool content we are utilizing here? Here we can utilize a cooling water. A cool water or natural normal ambient temperature water. So that is known as the cooling water. Okay. So here we are using a condenser, one device. That device, one path we can flow the steam, and another path we can flow the normal water or ambient water. So automatically what happens? The temperature is transfers. Okay. So here the steam is going through the pipelines. So above the pipelines we are sending the water content. What happened? We have two different temperatures. That means it takes a heat transfer. So that means at high temperature steam loses its temperature and that steam is converted into the full of water content. Okay, so that is the basic thing. So this is the equipment of a condenser. Condenser is a device which converts steam into the liquid format. Okay. For condensing process we need to supply the cooling water. So from where we can take the cooling water? We can take possibility of positions there, maybe rivers or canals. After that also we have some more temperature is present here, because just here we are converting the steam into the liquid, but the liquid content may be high temperatures. So I would like to convert the temperature also, or cool down the temperature. For that process we are using the cooling towers. So generally if you see any power plant, cooling towers are available in a thermal power stations in a large tower format. So this is the structure of a cooling tower. Maybe it is constructed by cement materials. Okay. What is the function of a cooling tower? So simple here. The steam is injected here. Hot water is injected here. And maybe some air is entered into the atmosphere. So when the hot water is contacted with a fresh air, automatically it loses its temperature, because temperature variation is there. There is a heat transfer process is done by the atmospheric air. Okay, so that is the functioning of a cooling tower. It cools down the water. After the cool water, that cool water we can utilize maybe a condenser process. That cooling water, what we can do? That cool water we can utilize for a condenser working process. And also we would like to know about the some other circuits are available here. So what are the other circuits here? So the only remaining thing is ash handling system. So what is meant by ash? After the combustion process or burning process, that coal is converted into the ash format. Okay. So if the ash is present in the furnace, there is no chance to refill the fresh coal. So that means we need to remove the ash continuously. So ash removal process we need it. Okay. So after, for example, this is the furnace. From this furnace we are removing the ash by using an ash handling plant. We can utilize the different components here. We can discuss later. What are the components we are using in the ash handling system? What are the different types of coal handling plant? We can discuss in the latter part. And now we can discuss only some plant is there. That system process is the remove the ash content. So after removing the ash, what we require? We need one storage point. Okay. So in the process of thermal power stations construction point. Okay, site selection process. So we also discussed about these points. Air storage is required, and coal storage is required, and coal availability is required, fuel availability required, water availability is required, and transportation facility is required. Load center is nearer to the nearer to the power point. So these are the site selection conditions. Okay, so that's why we need a storage of air storage, coal storage. So we require a large amount of space. Area also required for the thermal power stations, and the strength of the land also required. So these are the requirements of a thermal power plants. I think it's clear about a steam power plant layout. So this entire process is a systematic process. It is done by one by one clearly. Finally, the thing is chemical energy of a coal is using for heat energy. That heat energy is using for a conversion of water into the steam. That is the kinetic energy. That kinetic energy is converted into mechanical energy by using of a turbine, and that mechanical energy is converted into the electrical energy by using of a component of a generator. So this is the entire plant layout of a steam power plant. So it's a very important for a examination point of view. Okay, please go through it very carefully. And the second thing, and the thing is, so fuels for a steam generation. So as usually we have discussed the entire plant layout. The important thing is steam generation. For the further process, we need giving through the fuels. In the last class, we are discussing only coal content, but the fuel means only the fuel as a coal? No, we have several types of fuels. Okay, so that's the thing. So we need different types of fuels. So what are the different types of a fuel content? Fuel may be solid, fuel may be liquid, fuel may be gas. So these are the things: solid, liquid, maybe gas also. We can utilize the gas also as a fuel. So these are the gases. And the selection of the type of fuel depends upon the availability of fuel and economic considerations. So we can choose the steam power plant. We know that the steam power plants occupy 50% of a power generation in India. Why we are choosing a steam power plant mostly? Because the thing is, it's a very cheaper than the other power generating techniques. So the simple thing. So that's why we are using economical considerations. Steam is a low power, low economic. So that's why we are going to the steam power plants. So here, just I would like to introduce here to types of fuels. The important types of fuels are the gaseous fuels, liquid fuels, and the solids. What is the gaseous fuels we are using? What are the liquid fuels we are using? What is the solid fuels we are using? Okay. So see here, gaseous fuel. So at gaseous, especially we are using fossil fuels. So fossil fuels are there, artificial gases also available today now. So what are the natural gases? Natural gas means it contains the methane content, CH4. So from where we will get the methane here? So methane is simply we will get by using a from the earth rounds. Okay. So natural gas contains the maximum content of a methane, about 60 to 65% of a methane is available. And natural gas is generally obtained from the gas wells and the petroleum wells. So the major so it contains the other than the methane also hydrogen, nitrogen, and some other contents also available in the gaseous form. So see here. So gaseous fuel generally. Okay. So this is the gaseous fuel we are using. So see here in this image. So this is the gas flow. So that gases is entering into the chamber, and here firing process takes place. And these are the turbine here. So this turbine converts the energy, kinetic energy. So here combustion process gives a kinetic energy. This is a gas power plant, gas turbine power plant. And next one is the liquid fuels. So generally what is meant by liquid fuels? Liquid contains, we know that all the petroleum fuels, crude petroleum and byproducts like diesel. So most of the cases where we require high amount of power, low amount of power, at that time we can utilize a diesel power plant. Why we are using diesel power plant means very less means it's a very costly process. For example, 1 liter of diesel around 70 to 80 rupees. So that means it's a very high process. That's why we don't utilize the diesel power plant in a large amount of power required conditions. Only when we are required a small amount of power, we can utilize the diesel power plants. And generally in a petroleum products, carbon content is very high, 80 to 85%. So that means the heating value is very high for the liquid fuels. And hydrogen content is 10 to 15%. So hydrogen have a highly flammability conditions. So simple diesel power plant operation here. See here. So we are using the diesel fuel and the combustion takes place. So when the diesel power plant is operated, we will get the mechanical energy. That mechanical energy is converted to the electrical energy by using a generator. The principle is same, but here we don't utilize any water content. Okay. So here we don't utilize the water content. We are using the combustion process of a diesel engine. Okay. Already do you know very well about the diesel engines, because already in a second year we can learn about all the IC engines types, and laboratory also perform so many experiments. And our content. So that means a steam power plant. Unit 1 consideration of a coal. So this is the coal burning process. So coal is burning like this. See the image here. Coal is burning like this. So what are the contents? For firing, we read carbon content. Carbon is very important for the firing processes. So solid fuels, coal is a major fuel used for the thermal power stations to generate the coal. So what is the chemical composition here? The chemical composition is carbon, hydrogen, nitrogen, oxygen and sulfur. Okay. So we are discussing about coal. Coal is used for the burning process. So what are the different types of coal? So coal have majorly 6 different components. 6 variations are there. That is known as the peat, lignite, bituminous, subbituminous, anthracite, graphite, based on the carbon content. And the one more thing, important thing is, so peat means that is the starting stage of conversion of a coal. So how the coal is generated? The coal is generated by using under the earth after lakhs of years, minimum lakhs of years, the coal is converted into the vegetable is converted into the coal format, that is the peat. After the peat stage, that is the lignite stage. After the peat, after the bituminous state, that is the after the lignite state, that is the bituminous. So generally the bituminous is having a black in color or dark brown color also. And subbituminous, so subbituminous is the stage in between the bituminous and the anthracite. So generally we are using for the steam turbines. And anthracite, this is the best coal. It has a high carbon content. Okay. So generally anthracite is a highest rank of the ignitable coal. Okay. So it has a hard, black and glossy and primary space heating. And the last one is the graphite. So it is not that much giving a combustion process. Generally we are using the graphite for the pencils and the lubrications process of a power stations. Okay. Thank you. So queries. So if you have any queries, just send a mail gradhakrishna_VRTS @vignan.ac.in. Okay, clear. Thank you.